All right, so for one-sided limits, we're going to talk about a function that you have seen in your book. The function is, they do the other one that I did in the video. So they do y equals x squared minus 4 over x minus 2. In the other video, I did it with x plus 2. So we're going to reanalyze that one as well. And the graph of that function is going to be something like this. So let's graph it here. You're going to be looking like a line. But then you're going to go, and I had to cross here, but tough luck. So we're going to do here a little hole. I'm going to keep going. Of course, in your book, you have the perfect graph. We'll look at it there as well. So, of course, not very well to scale, but good enough for us. So what you have going on here at x equals to 2, in this particular example, you have that the limit is tending to 4. So you've analyzed this one in your previous lecture or your previous notes. So we do the limit from the left and the limit from the right, and that's what I'm going to be talking about. As you approach x equals to 2 from both sides, you're going to go to y equals to 4 as x comes to 2. As x approaches 2, y approaches 4. So that's what we said, that the limit as x goes to 2 of this function, let's call it f of x again, we said that this limit is 4. However, you have the next graph on that same set of graphs where you have the function y equals x minus 2, and they call this one g of x over x minus 2. And here the graph, you're going to have 2. And then let's go up to 1. It's too close, -1, that's okay. And the graph is going to be doing this. When you are on the left-hand side of this x equals to 2, to the left-hand side, this is going to be a negative. And I'll tell you why in 1 second. And when you're to the right, you're going to have a little bit of a jump. So why is that? Well, let's take a value and see what happens. So let's say we grab here -1, and we evaluate this function there. At x equals -1, g of -1 equals this. So ignore my at the moment. So when you plug it in, you get the absolute value of -1 minus 2 divided by -1 minus 2. Just plugging -1 in place of x. And here I get -1 minus 2 is going to be -3, absolute value of that, divided by -3. The absolute value of -3 is +3, and the -3 remains like that. So when you divide it, the only thing that remains is a -1. That's why I'm getting, for every value to the left of 2, I am getting this value of -1. When I go to the right, however, so let's go to, say, for example, 3 or 4. Let's say 4. So this is what I should have written as x equals 4. G is going to be taking the value of, well, 4 minus 2, evaluating at x, right? So over 4 minus 2, which is the absolute value of 2 over 2, which is 2 over 2, which gives you +1. Now, we don't know what happens at 2, because you get 2 minus 2 is 0, divided by 2 minus 2, which is 0. Again, 0 over 0, we don't have it defined, so that's why we leave the open ends or the open endpoints on both sides there. All right, but here, then there's no limit, right? That when you're traveling on one side and the other, you're not approaching the same value. However, we will say that the limit on this side, I am approaching some value. So what I'm going to say there, I'm going to write it here, is that the limit as x approaches 2, and I'm going to put this minus to say from the left, is going to be, and this function we call the g, is going to be -1. But on the other side, the limit as x approaches 2 from the right. So this is not -2 or +2. It's 2 from the left and 2 from the right. So when I approach 2 from the right, so from this direction, the value that g seems to be taking but won't take is going to be 1. But now you see that the limits are different. So when the limits are different, the one-sided limits, so the limit from the right is different than the limit from the left, we say the limit does not exist. And when the limit from the right is the same as the limit from the left, here you have that this is going to be the same as the limit independent of what side you go to or you come from, you're going to get the same value. So when the two one-sided limits coincide, you say that the function has a limit, and the limit is that same one-sided limit. And when the two one-sided limits do not exist, then the limit itself does not exist. So that is the idea of one-sided limits, and those are going to be useful to us whenever we have functions like the graph that you have on your book that they called, I think, h of x, and it is, I'm going to just draw it small here, and it looks something like this, which is 1 over x minus 2 squared, and the function is something like this. There. So when you have that, then you're looking at the one-sided limit as x approaches 2. This is going to be going up to positive infinity from this other side as well. So the one-sided limits will also be very important to us whenever the limits tend to go out to infinity. All right, but I wanted to clarify that for you guys before you jump onto the lecture, because it may not be as clear as we want it. So we'll leave it at that for this video, and I'll see you in the next one.